Welcome to the fourth experiment in machine learning lab. So the title of the experiment is to build an artificial neural network by implementing the backpropagation algorithm and test the same using appropriate data sets. So what is actually an artificial neural network? An artificial neural network is the piece of a computing system designed to simulate the way the human brain analyzes and processes information. It is the foundation of artificial intelligence and solves problems that would prove impossible or difficult by human or statistical standards. So backpropagation is a kind of uh, learning algorithm applied on the multi-layer neural network. So what is a multi-layer neural network? So multi-layer neural network consists of the series of layers. The first layer is called the input layer, and there can be one or more middle layers which are called as hidden layers, and there is a output layer. So each layer contains any number of nodes, and every node in each node is connected to the adjacent node in the every other layer. Okay, so it is a complete network of connected nodes. So the hidden layer is the name suggests that the output, so it is not the output of the hidden layer is not being visible to the at the end, and the output of the hidden layers is used by the used as input by the output layer. The output of the hidden layer is used as input by the output layer. So hidden layer takes input from the input layer. So input layer acts as a is just a processing element. There can be more than one hidden layers, so depending on the complexity of the data. So as we increase the number of layers in the network, the computation time or the training time of the network will be more, but at the same time it takes a lot of time to stabilize the weights, as well as lot of computational power is needed. So what is a backpropagation algorithm? As we seen, backpropagation is a learning algorithm which is nothing but which adjusts the weights of the network used in which adjusts the weights that are being available in the network. So the backpropagation algorithm has two stages. In the first stage, the data is moved from input to the output layer, and in the second stage, the output layer, the error is calculated at the output layer, and the difference is being fed back to the is fed backward direction. So hence the name is called backpropagation. The error is being propagated back so that the weights are being adjusted accordingly. Okay, so let us see just have our eye on the backpropagation algorithm. So backpropagation algorithm takes 5 inputs. One is training example, and second is eta, that is a learning rate. Third is n in, which is nothing but the number of input layers. N out, that is the number of hidden units, and n out, which is number of output units, and n hidden is the number of hidden units. And the input from unit I to unit j is denoted as xji, and the weight from unit I to j is denoted as wji. Now the input is a combination of the input vector and the target output vector that is x and t. The first step is to create a feed forward network with n in inputs, n hidden units, and n output units. Then the second step is to initialize all the networks with a small random numbers. We start the weight calculation by assuming a small random numbers for each of the weights. Then until termination condition is reached, for each input data and the output on the output vector, input vector and the output vector in training example, do the first step is propagate the input forward through the network. So first we will move in the forward direction, that is input x vector to the network and compute the output of every unit. Now once you compute the output, then find out the difference. So what is actually the target output and what output the network is producing. So when we take the difference of that, we will come to know what is the error. So that is the second stage. Propagate the errors back through the network. Now for each network output unit k, calculate the error term delta k as delta k is ok of 1 minus ok into tk minus 1 minus ok into tk minus ok. So that is, now here we are we are using ok minus 1 minus ok, which indicates that since we are using the sigmoid units, the derivative of the sigmoid unit is again a sigma. So sigma dash of y equal to sigma y into 1 minus sigma y. So hence the units that are used in the backpropagation algorithm, the network nodes are the sigmoid units. So hence we are taking ok into 1 minus ok, and then tk minus ok, that is target minus the output produced by the network, will give the actual error. Then next, this is at the output layer. Since we do not have the target output for the hidden layer, so we will just take the error from the input from the output units, and then we multiply that with the incoming edges of that node. So that is nothing but the number of edges that are outgoing from the particular node to the particular node in the output unit. So that is delta h, that is error in the hidden unit, is OH into 1 minus OH sigma k belongs to output WKH into delta k. WKH is nothing but the weight of an edge from kth node to h, and that is from h to kth node in the output unit, multiplied by the error at that output unit. Then we update the weight by using Wji is equal to Wji plus delta Wji, where delta Wji is equal to eta delta j xji. So the backpropagation algorithm uses the stochastic gradient descent to adjust the weights. So let us see the Python implementation of the backpropagation algorithm. Let us see the Python implementation of the backpropagation algorithm. So here we are using the NumPy array. So the NumPy array, it is used for performing the numerical computations. So the function that we are using in the NumPy is the we are using the NumPy module to perform the we are performing some numerical operations. So for that purpose we are importing the NumPy module. So the first step is we will create two arrays, input arrays and the output array, np.array and np.array. We use the function np.array, and the first is 291536. So what we can say is a person who sleeps for 2 hours and studies for 9 hours, a person studying for sleep for 1 hour and studies for 5 hours, and a person sleeping for 3 hours and studies 6 hours, and their corresponding percentages of result is 92%, 86% and 89%. Means a person studying for 2 hours and sleeping for 9 hours, or a person sleeping for 2 hours studying for 9 hours scores 92%. A person sleeping for 1 hour and studying for 5 hours scores 86%, and a person sleeping for 3 hours and studying for 6 hours scores 89%. So this is a one type of what we can say, one type of assumption for the input and output. So x is input, y is output. So we will use x equal to x divided by np dot a max. Okay, so what is this np dot a max? So np dot a max is a function that is it performs the maximum of an array or maximum along the axis. So that is along the it returns the maximum value. Now the next is y equal to y divided by 100. So why we are converting this to why we are dividing it by 100 is to in order to have a standardized normalized values. Okay, so hence we have y as 0.92, 0.86 and 0.89. The units used in the backpropagation algorithm, that is that units used in the multi-layer network where we are applying backpropagation is the sigmoid unit. Okay, so what is a sigmoid function? So sigmoid function is given by the expression 1 divided by 1 plus e raised to minus x. Okay, so that is the equation of the sigmoid function. So that is represented as return 1 divided by 1 plus exponential is present in the np package. So hence np dot exp into minus x. So that is 1 divided by 1 plus e raised to minus x. Then we know that the derivative of the sigmoid is again it is a sigmoid, so hence it is x into 1 minus x. So what is this epoch? Epoch is nothing but the number of iterations that are to be performed. Okay, so that specifies the number of iterations to be performed. Then what is LR? LR is the learning rate. So what is the, we know that backpropagation algorithm needs one input called learning rate, which is represented as eta in the algorithm. That is eta is here, it is nothing but 0.5. Then we need to specify how many neurons are present in the input layer, hidden layer and the output layer. So in the input layer we have two neurons, that is we have two features 2, 9, 1, 5, 3, 6, and in the output layer we have one variable, and in the hidden one neuron, and in the output layer hidden layer we have three neurons. Number of hidden layer neurons is 3 in the output. Number of neurons in the output layer is 1. Now initially we need to start with a random that is small random number. So for each of the edges that are present in the neural network, so we need to assign the values for the random values for the edges. So WH equal to NP, that is weights at the hidden layer, is nothing, it is equal to np dot random dot uniform. So uniform distribution means the values are always in the range 0 to 1, any random number in the range 0 to 1. Size equal to input layer comma hidden layer of neurons. So between input layer and the hidden layer we are taking the weight value weights. Then we know that the network also has a bias. So hence np dot random dot uniform size equal to 1 comma hidden layer neuron. So we attach a bias to the hidden layer. Then we also assign weights to the output layers neuron. So that is np dot random dot uniform size equal to hidden layer neuron comma output neuron. Means what we are doing here is we are generating if we execute this statement np dot random, we are actually generating an array. Okay, so if we look into this, we know that there are two input neurons, two neurons at the input layer and three neurons at the hidden layer. So hence if we execute, so how many weights that we are getting here is, we look at the output of the WH. So we have 2 rows and 3 columns. So what it means, so 2 rows are nothing but for the 2 input neurons, and 3 columns are nothing but for 3 hidden layer edges. So that is, each and every node in the input layer is connected to the hidden layer. So that is what the so these are the random weights which are in the range 0 to 1. So similarly we use the same kind of representation for the weights at the output, and we associate a bias to the output layer. The next is, we are now going into the this back propagation algorithm. So till now we set up the multi-layer neural network. Now we are applying the back propagation algorithm. So what actually we are doing here is, we iterate it for some thousands of times. Then the h input 1 equal to np dot dot, np dot dot, what is that dot? Dot is nothing but a dot product of the input vector x and the wh. We know that the neural network, each node is having two things. One is summation, one is transfer. So the transfer is represented by the sigmoid, and the summation is nothing but the dot product. So hence we are taking the dot product of input and the weight vector. Then we will add bias to it, and that will become that will give you the summation part, and then we apply sigmoid to the summation part, and that is the output of the hidden layer. So what is actually hidden layer activation? It is sigmoid of input. Then output is nothing but np dot dot h layer activation comma w out. So the dot product of the hidden layer output with the weight of the output unit, that will give you the output. Then we will apply the so the first these two things are with respect to the hidden layer. So for hidden layer, the input is the coming from the input layer, that is nothing but the weight and the input vector, and we will take the dot product, we will add the bias, and we will calculate the sigmoid. The same thing we do for the output layer. For the output layer, what is the input? Input is from the hidden layer, so that is h layer activation, then w out. So that is the dot product of the weights and the input. Input is here the hidden layer, then we will add bias to the output, then we take the sigmoid of the output. Then what is according to the error? So we know that in the back propagation algorithm, error is nothing but y minus output. So what is y? Y is target, y minus output is nothing but tk minus ok. Okay, so that is error equal to y minus output. But what we need to do, so here y minus output is now associated with an derivative, that is ok into 1 minus ok. So derivatives underscore sigmoid of output. So hence what is the output? E0 into derivative. So that is what we will get the output. Now error at the hidden layer, what we have? We have the dot product of weight into dot t. So what is this t? This is a transfer. We know that we can multiply the two matrices only when the columns in the first matrix is equal to the rows in the second matrix. In order to do that, we will make a transpose of the matrix. So d underscore output into dot of w out in. So that is what this term delta k into wkh is being represented with this part. Then again we have oh into 1 minus oh. So that is hidden grad equal to derivative of the sigmoid layer, that is activation. Then what is the entire error available at the hidden layer? It is d underscore hidden equal to eh, that is eh is nothing but this part into the hidden grad, that is gradient is this part. So hence the w out, the change in weight equal to earlier weight plus a hidden layer underscore activation transpose the dot product of output into that is what this equation eta delta j x j I. Okay, so eta is learning rate, so learning rate is LR. It is the dot product of the output difference and the hidden layer activation. Then what is the weight update at the hidden layer? It is the dot product of input vector and the hidden layer into the learning rate. So learning rate here we have taken it as a 0.5. So after performing this, we will just print the output. So what is the output? So I have given the input as this value. So my actual output is to be this, but my predicted output with my neural network, I am able to get this output. So hence, if we compare the output, the 0.92, 0.89, 0.86, 0.87, 0.89, 0.89, so the actual values are near to the predicted values are very much near to the actual values. So hence we can say that the network is trained to nearest to the closer values. So the one modification we can do is we can reduce the number of iterations. Instead of 10,000 we can make 5,000 and we can execute the remaining things. So again there will be no much change in the output, but the number of computations are being reduced. We can also check the effect of the learning rate. Instead of 0.5, if I make it as 0.05, then there will be again change in the output. So that is we can again not much effect it is being playing, but we cannot make this as 1.5 or something that random values. Okay, so the learning rate is it finally influences on the entire network learning. Okay, so this is how we will be learning this is how the neural networks learn the learn the weight updates. Okay, so that's for the experiment number 4. Thank you.